Standard form is another way that we're able to do our graphing. The only problem is that the majority of the extra information needs to be calculated. Now, the A value, which is the exact same as the A value in our vertex graphing form, well, that A value still tells us the direction that the graph opens, as well as it talks about the width. Of course, there should be a D there, and I'll make sure that that's fixed up. But the extra bit of information is that the C value actually is telling us what the Y-intercept is. So that's one thing that you should know. The things that the standard form helps us to calculate involve the vertex and the X-intercepts. So the vertex is calculated by the formula negative b over 2a, which would be the h value of the vertex, and the c subtract b squared divided by 4a will be the k value of the vertex. Another way that I like doing it, I do it in pre-calc as well, is it's the exact same h value, negative b over 2a, but I just change it that it's just c subtract a h squared. So whatever number you get here, you just have to plug it in and square it. Our x-intercept are calculated by factoring the quadratic and solving, or by using the quadratic formula. So let's do a few things. In our first one, we're going to determine the x-intercepts, y-intercept, vertex, axis of symmetry, domain, and range. So first one, in order to find out our x-intercepts, well, one way we can do it is to factor. So our factoring, we set our y equal to 0, and then we are able to continue. The first step to factoring is our GCF. So we factor out the 2. Oh, sorry. That should be a 7. Then we could do our product and sum. A product of 1 times 6. A sum of 7. Well, the two numbers that would work there would be 1 and 6. Positive 1 and positive 6. So we make our two sets of brackets. Go x first spot, and I put my positive 1 and my positive 6. To find out our x-intercepts, though, we need to set our factors equal to 0. So the x plus 1 equals 0, and the x plus 6 equals 0. This one, we'd be subtracting the 1. And in this one, we'd be subtracting the 6. Our y-intercept, as I had stated before and above, the y-intercept is just whatever our c value is. In this case, it's 12. We'll also calculate what our vertex is. Our vertex is calculated by using this formula. We'd have to take negative of our b, so negative 14 over 2 multiplied by 2, which is our a. Our c value, which is 12, subtracting our b squared, so 14 squared divided by 4 times our a, which is 2. And we continue on. So negative 14 over 4, while subtracting 196 over 8. So negative 14 over 4 would reduce to be negative 7 over 2, or negative 3.5. Sometimes when we're graphing, it's easier to deal with the decimal. Of course, if we're calculating things, just strictly calculating, absolutely negative 4 over 2 or negative 7 over 2 would work out really nicely. Say 196 divided by 8. is 24.5. So 12 subtract 24.5. Would be negative 12.5. Axis of symmetry, as we had talked about before, is just going to be the x value of our vertex. Our domain, oh, sorry, went a little bit too high there. Domain is all real numbers. And our range is all of our y's. Now let's look at it. Our a value is positive, which means it's going to be going up. So it's going to be our y values that are greater than or equal to the y value of our vertex, negative 12.5. Of course, y is still being an element of the real numbers, but we're still good there. Now we can identify and do a few more things here. Now, even though this vertex is a little bit off the graph, it can still be done. So negative 3.5, negative 12.5 will be about right there. This one for sure will not be the greatest to do by the staircase method, but we can identify a whole bunch of good other things. For example, our two x-intercepts. Oh, sorry, negative 3.5. Sorry. Let's move that to negative 3.5, negative 12.5. There we go. We can identify some other key aspects, like our x-intercepts, where it's crossing the x-axis at -1 and -6. Our y-intercept is 12, so it's a little bit off our grid again. That, I think, is a little too high. Put it there, about there. That looks a little better. Our axis of symmetry, we don't have to sketch, but we can graph our parabola. You know it's going to be going up. Add our arrows. And because that a value is actually 2, and the 2 is greater than 1, this would be considered to be a relatively narrow parabola. Our next one, we're going to do the same kinds of things. But the biggest problem is this one cannot be factored, which means we're going to have to use a quadratic formula. And once again, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I do apologize if my singing is a little bit pitchy, but I don't mind it. I don't mind singing this song. It's catchy. All right, x equals negative b, so -6. Our b value is there. Again, help identify our few key points. Add or subtract b squared. So 6 squared, subtracting 4. Actually, I'll just keep things nice. 4ac, so our a value is -1. Our c value is 10. You may need to do a nice review when we talked about our quadratic formula. If you don't know how to work with this, so go and do that. X would equal -6, adding, subtracting, 36. So that would all turn into a positive 40, all over -2. -6, add, subtract, 76, all over -2. So our two answers will be -6. Add the square root of 76, divided by -2, and x equals -6, subtract the square root of 76 over -2. This answer, plugging into my calculator, add square root of 76 divided by -2, 1.36, and this one would be 7.36. Alrighty, y-intercept. All our y-intercept again is our c value. So our y-intercept is just y equals 10. To find out our vertex, we're going to be using our formula. You could just use this one as well. Again, just whatever answer you get here, you're going to have to plug into the h value. So -6. This one would work out really nicely. The c value is 10, subtracting b squared, 6 squared over 4 by a, which is -1. So -6 divided by 2 times -1, well, that works out really nicely as 3. That's 10, subtracting 36 over -4. All of this then works out. -36 and -4 would be +9. Really? Yeah, that would be. 319 would be our vertex. Now you won't always have vertices that, or vertexes that are going to be way off your grid like these two. Some of them will be right on your grid. I just show some examples that apparently are not the greatest for graphing, but we can still do it as best as we can. Our axis of symmetry will be x equals 3 because it's the x value of our vertex. Our domain, all real numbers. Range, y values. Now, because this would be a graph that would be going down, because of that a value being negative, it'd be less than or equal to the y value of our vertex, 19. So let's do what we can. So for example, our vertex is 319. So it would be like way up here. Our y-intercept is 10. Our two x-intercepts are -1.36 and 7.36. So we can do as good of a sketch as we can, given our current information. This one for sure is not going to be the greatest, but it does its purpose. And one final example, the x-intercepts of a quadratic function are -1 and 4. The y-intercept is 12. Determine the equation of the quadratic in factored and in standard form. So let's put into context. We have a, that doesn't look great. Let's actually use some lines. So if we have a Cartesian plane and we have x-intercepts of -1 and 4, the y-intercept is 12. Well, if we were just considering what our x-intercepts are, we could have a parabola that would look like that, or a parabola that would look like this. Let's make that actually go through. So we could actually have an infinite amount of solutions that would just be going through these two. Now, each and every single one of those would have a certain form. An A, and then we'd have some coordinates. So just for our x-intercept, we'd have some kind of number factored out, and we'd have some kind of factors that we'd have to set equal to 0. But we have to be careful because we have to be able to have a quadratic that goes through that positive 4, goes through that y-intercept of 12, and goes through that x-intercept of -1. So we're going to have to do a few different things. For example, this -1 means that the factor would have to be x plus 1. This positive 4 means the factor would have to be x subtract 4. So overall, what we are going to have to do is we're going to have to solve for what the a value is. So let's go through a few things. So it's going to be an x plus 1 and an x subtract 4. We don't know what the a value is, but with every other bit of information, we actually do have that y is 12. But if the y is 12, from there, the x value is 0, which means both of these x values would actually be 0. This will then allow us to finish off and solve for what our a value is. So I'll leave it blue. So 12, except for the a, I'll leave that green. 0 add 1 is 0, and 0 subtracting 4 is -4. So we'd have 12 equal to a being multiplied by -4. To solve for the a, we then divide by -4. So our a value would be -3. So simply by plugging our a value back into here, we'd have a factored form of y being -3, x plus 1, x subtract 4. So there's our entirely factored form, where our x-intercepts would be the -1 and the positive 4, and we can go from there. But I also want to do things in standard form, because we can remember our practice and our procedure for distributing with something like this. The first thing that we would want to do is distribute our -3 inside our first set of brackets, because we want to do it one step at a time. So the -3 into the first set of brackets will be a -3x subtract 3. From there, then we do the rest of our distribution to finish off our equation. So -3x multiplied by x will be a -3x squared. Add our 12x, subtract a 3x, and add 12. Our standard form of this quadratic by combining our like terms will be -3x squared, add 9x, add 12. Meaning, if we were to factor this out, it would come back to here. At the same time, we can read right from here, yep, our y-intercept is positive 12. And there we go. You can go have some fun.